Good morning, HOD Professor A.K. Chaturvedi sir, my seminar guide Dr. Vijay Patil sir, faculty members, and my batchmates. I am Shoaib Dyer, currently pursuing my bachelor's degree in aeronautical engineering from University Department of Rajasthan Technical University, Kota. Today, I am pleased to be here in front of you all to deliver the presentation on my seminar topic, electric propulsion. Electrical propulsion was first developed in the 1960s by both the United States and the Soviet Union. The electrical propelled satellite launch was SART first. It used electrical power to accelerate a propellant by different possible electrical and magnetic means. The use of electrical power enhanced the propulsive performance of electrical propulsion thrusters. Electrical propulsion required very little fuel to accelerate spacecraft. Classifications of electric propulsion. We divide electrical propulsion into three categories. First one is electrothermal propulsion. An electrothermal engine using electrical power to heat a gas, causing it to expand through a nozzle and generate thrust. Its examples are Electrojet and arc jet thrusters. A second one is electrostatic propulsion. Thrust accelerate heavy change ions by means of purely electrostatic field. Its examples are ion thruster and Hall effect thrusters. And third one is electromagnetic propulsion. A thruster is considered electromagnetic if ions are accelerated either by the Lorentz force or by effect of an electromagnetic field. Where the electric field is not in the direction of acceleration, examples are magnetic plasmodynamic thruster and pulse plasma thruster. Register-jet thruster. Register-jets are electrothermal device in which the propellant is heated by passing through a resistively heated chamber before entering a downstream nozzle. The increase in exhaust velocity is due to the thermal heating of the propellant, which limits the specific impulse to low level. Arc jet thruster. An arc jet thruster is also an electrothermal thruster that heats the propellant by passing it through a high current arc in line with the nozzle feed. While there is an electrical discharge involved in the propellant path, and plasma effects are insignificant in the exhaust velocity because the propellant is weak ionized. The specific impulse is limited by thermal heating to less than about 700 seconds. Ion thruster. It employs a variety of plasma generator techniques to ion a large fraction of propellant. These thrusters utilize biased grades or grids to electrostatically extract ion from the plasma and accelerate them to high velocity at voltage up to and exceeding 10 kilovolts. Ion thrusters features the highest efficiency from 60% to 80% and very high speed impulse from 2000 to over 10,000 seconds. Hall thrusters. This type of electrostatic thruster utilizes a cross-field discharge described by the Hall effect to generate the plasma and electric field established perpendicular to an applied magnetic field. Electrostatically accelerate ions to high exhaust velocities while the transfer magnetic field inhibits the electronic motion that would tend to short out the electrical field. Hall thruster efficiency and specific impulse is somewhat less than that actually in ion thrusters, but the thrust is give higher power than other technologies. Magnetoplasma dynamic thruster. Electromagnetic device that use a very high current to ionize a significant fraction of the propellant and then electromagnetic force in the plasma discharge to accelerate the charge. Propellant, since both the current and the magnetic field are usually generated by the plasma discharge, empty thrusters lead to operate at very high power in order to generate sufficient force for high specific impulse operating. Pulse plasma thruster. A pulse plasma thruster is an electromagnetic thruster that utilizes a pulse discharge to ionize a fraction of a solid propellant ablated into a plasma arc and electromagnetic effect. In the pulse to accelerate the ions to a high exit velocity, the pulse repetition rate is used to determine the thrust level. And this is the table shows the comparison between these thrusters. Ion thrusters. They produce thrust by accelerating ion through the application of an electric field between two grids, due to which plasma is formed in chamber by ionizing the propellants. There are several ways of ionizing the gas, which we will discuss in next slides. Apart from that, electrons are also ejected from a separate cathode place near the ion, called the neutralizers. To ensure that equal amount of positive and negative charges are emitted, xenon is often used as propellant, and typical values of specific are around 3000 second. The main functional elements in an ion thruster are ionization chamber, grid neutralizer, and power supplies. And this is the systematic diagram of ion thruster engine. Principle of working. The previous systematic thruster diagram illustrated the function of a graded electrostatic ion thruster. On the left side, neutrons atom of the propellant move from storage tanks into the ionization chamber. Simultaneously, an electrode fires electron into the chamber with high velocities, and these electrons knock out other electrons of the neutron propellant atom to create ions. As a result, the ionization chamber became filled with electrons and positive ions. At the other end of the chamber, there are two grids. They are connected to a voltage source that maintain a static positive charge on the inner grid and an equal and opposite negative charge on the outer one. Two effects combine to remove many of the free electrons from the ionization chamber. They move faster with the same amount of thermal energy and have a greater chance of collecting on the grid. Soon, positively ionized gas plasma builds up in the chamber. Types of ion thruster. There are different ion thruster depending on the ionization method employed. The most commonly used are electron bombardment thruster, contact ionization thruster, radio frequency ionization thruster, and many more. Advantages. Fuels in ion thruster last longer than conventional chemical thrusters. It is comparatively safer than a chemical fuel thruster. They are much easier to control. Ionic propulsion provides lots of exhaust velocities. Ionic propulsion lets spacecraft reach their destination using very small amount of fuel. This reduces risks, design complexity, and cuts down its cost. It weighs less than a conventional rocket engine. It has very low emission. Applications. Electrostatic ion thruster are mainly used for orbit transfer, adjusting altitudes, and cargo transport in space stations. Ion thrusters are seen as the best solution for the following missions, which only require high change in velocity and rapid acceleration isn't necessary. It is ideal for long-term deep space missions, low thrust station keeping, and at last also used in commercial and defense services. First electric space mission, SERT-1. The SERT-1 was only the first electric satellite. It was also the first spacecraft to incorporate any kind of electric propulsion. The SERT-1 launched on July 20, 1964. It was launched as an experimental satellite, and therefore the satellite total life was 1 day only. The SERT-1 tried two different grid ion thruster. The first one was 8 centimeter diameter cesium contact ion engine. Unfortunately, there was a mishap with the electrical circuits which prevents the engine from starting. The second engine was mercury electron bombardment ion engine. This engine ran for 31 minutes, becoming the first electrical engine ever to operate in space. Now the conclusion part, the electron ion propulsion system is the next step in the mankind for progress into space exploration in the near future. Electrical propulsion has the potential to interplanetary manned missions to Mars and possibly even mission to the moons of Jupiter. The simple fact that the fuel efficiency of electric propulsion is so great makes it ideal for communication satellite, and area in which the electrical thruster are already being widely used. And these are the references. Any questions?
Yes, what are ion engines?
Ion engines work by expelling a continuous beam of charged particles which pushes the spacecraft forward. The energy is fed the engine comes from the solar panels. Thereby, these engines called solar electric propulsion engines.
Can ion engines be used to take off from Earth?
No, because ion engine generates a very gentle thrust, so it can't be possible. Any questions?
No.
Thank you.